we can see from the text 2.3 convolution. Okay, we are given an x of n, which is u of n, and h of n, a to the power minus n, u minus n. Right? Here a is a number between 0 to 1, and use direct convolution. Okay, to find y of n. Let's write the formula first. Y of n is equal to summation for k minus infinity plus infinity x of k h n minus k, or x n minus k hk. What are it called? Now, let's see the sequences first. I can rather to use this one, for example, and let's draw the sequences first. Here is h of k. H of k, it's unit step, folded unit step. This means that I have to start from 0 when a is a small number and n in increase, so that's going to be a decreasing sequence, right? So something like this. Right? The first value, a to the power 0, is 1. Next, let's see x n minus k. Oh, sorry, this is not n axis, this is k axis. So when it is k axis, we have to reverse, right? U of n, that's going to be u n, so u n minus k with respect to k, which means that I have to take a sequence from 0, right? For n equals 0. And for example, for n equals minus 2, it's going to be this. So if I simply shift this with respect to n, I may have, for this sequence, I may have either here or let me show you another color. Here. N is here and here, so this corresponds to n is less than 0. This corresponds to n is greater than or equal to 0. Actually, less than or equal to 0, greater than 0, because that's reversed. Okay, so I have to split the sequence into two components. Then the first one, where n is less than or equal to 0, that's going to be summation. So the range of this, let me use another color, from minus infinity to to n. So minus infinity to n, or k. A to the power minus k. For n is greater than 0, so this is the case. Then from minus infinity to 0. A to the power minus k. So you can do the remaining. Again, we'll be using our identity. This is quite useful. Alpha to the power k, which is alpha to the power n1 minus alpha to the power n2 plus 1 over 1 minus a. Okay, so we can apply this to here. We can also write this as a reverse, minus n to infinity a to the power k. And similarly here, we can write this as from 0 to infinity a to the power k. And this is going to be a to the power minus n, a to the power infinity divided by 1 minus a. Here it's going to be a to the power 0 minus a to the power infinity divided by 1 minus a. A is a small number. When we get its infinite power, this is going to be 0. So here it is. And 1 over 1 minus a. Okay. Next question is about homogeneous solution of difference equations. It's another concept that we have studied. So that's 2.5 from the textbook. We have a causal airtight system. By the way, I am solving part A, airtight system. And y of n minus 5y of n minus y 1 plus 6y n minus 2 equals 2x n minus 1. Okay? Find the or determine homogeneous solution. Okay? In order to do this, we, as you might remember, we use a solution with the form. Okay? And then we can convert this into, there are two different symbolization. You can either, you can use either. It doesn't matter which one you want to use. But as you might remember from the lesson, we just use z to the power n minus 2, z to the power 2 minus 5z plus 6 equals to 0. This is taken 0 for homogeneous solution. So this is the equation that we have to solve and find z values. And apparently this is going to be z minus 2, z minus 3. Okay? Then the solution will have a form a1, z1, and a2, z2n. So then y of n I'm sorry, there is a student waiting in the waiting room. Y of n is going to be then A1, Z1 is 2, so 2 to the power n plus A2, 3 to the power n. So that's the homogeneous solution. One more example, it's about periodic sequences, 2, 7. Periodic or not? Let's remember how to determine whether a sequence is periodic or not. First of all, if a sequence is periodic, then we should determine its period. Usually it's written as with this form. Where n is period. And we usually check the frequency divided by 2 pi is equal to k over n or not. And this k and n are integers, numbers, okay? So we just check this, inspect this. If it's okay, if k and n is integer for this, then the period is n and this sequence is periodic. Now let's see part A, the sequence, given sequence is e to the power j pi n over 6. Okay, now remember that this is the form of e to the j omega 0 n, okay? Our exponential function, which was what we call eigenfunction, right? For Fourier analysis, for LTI systems, this form is eigenfunction. Now let's see, pi over 6 is my omega 0. So omega 0 over 2 pi is going to be pi over 2 pi 6, which is 1 over 12. So this is my k, this is my n. So the period is 12, so that's a periodic function, very periodic sequence. With 12. Okay? Part C, which is x of n, sine pi n over 5 divided by pi n. Okay, this is an interesting function. You have to be careful. Okay, this could be periodic, as this is omega 0, which is pi over 5, then it's going to be, its period is going to be 10. It's okay. But here we have a variable which is 1 over pi n, which means that that's inversely linear for increasing n. So this sequence cannot be periodic. Okay? Not periodic. Go to this term. But sine is the periodic one. The last one is part B, which is x of n e to the j pi n over square root of 2. So this has the same form of part A. We can write omega 0 over 2 pi, which is pi over 2 pi square root of 2, which could be n or not. Apparently, here it's going to be 1 over 2 square root of 2 is not does not have the form of k over n, since this is not integer, so not stable. Okay. And finally, there is one more example about you can take save the board, or I can. Okay, let me write here. Problem number 2.6. It's about Fourier transformation. We have just studied this. There's a difference equation, and x of n plus 2 times x n minus 1 plus x n minus 2. Okay, find the Fourier transformation as well as impulse response. Okay, so we use Fourier transformation, then we can take Fourier transformation on both sides. That's going to be y e to the j omega, which is 1 minus 1 over 2 e to the minus j omega. And on the right-hand side, we got x e to the j omega and 1 plus 2 e to the minus j omega plus e to the minus j 2 omega. And then h e to the j omega is going to be division. Simply divide y of j omega j omega divided by x j omega, which is 1 plus 2 e to the minus j omega plus e to the minus j 2 omega divided by 1 minus 1 over 2 e to the minus j omega. This can be written in different terms. 1 over 1 minus 1 over 2 e to the minus j omega, and the first term. The second term, 2 e to the minus j omega divided by 1 minus 1 over 2 e to the minus j omega, and plus e to the minus j 2 omega divided by 1 minus 1 over 2 e to the minus j omega. Now, we have to use Fourier transform table. You should remember which one we'll use. You might see that the Fourier transformation of this form is just the form of a to the power n u of n. Okay? So this is the Fourier transformation of this, where a is 1 over 2. So this one will be shifted version, okay, by 1, so n minus 1. And this is shifted by 2, so n minus 2. Then I can write the output as 1 over 2 to the power n, u of n, this is the first term, plus the second term, there is going to be 2 here. So 1 over 2 shifted by n, 1, n minus 1, u, n minus 1, plus 1 over 2 to the power n minus 2, u, n minus 2. Okay? So that's the impulse response of the system. That's enough for today. Please take the screenshot if you want to study later. I'll stop sharing.